It was just a picture, but it shook the entire field of modern astronomy. When NASA released the image from the James Webb Space Telescope, scientists were stunned. They saw a fully formed galaxy, bright, detailed, filled with billions of stars that appeared less than 400 million years after the Big Bang. According to all current models, the universe at that time was just darkness and chaotic gas. No galaxy should have existed. In the past, the scientific community claimed this was impossible. But James Webb captured the opposite. A mature galaxy with spiral arms and a clear, glowing core had appeared far earlier than anyone expected. So what is really going on? Were we wrong, or has something been hidden by the world of astronomy? In today's video, we'll explore this galaxy that shouldn't exist and why it might rewrite everything we thought we knew about the universe. When astronomers zoomed in on the strange new image from James Webb, they didn't expect to find a spiral galaxy. Not at that distance, not at that time. But the galaxy was there, beautiful, detailed, and impossibly old. It had elegant spiral arms tightly wrapped around a glowing center. Its shape looked just like the Milky Way, or Andromeda, except this one appeared when the universe was only a few 100 million years old. To understand why this is shocking, we need to understand what the early universe was supposed to be like. After the Big Bang, space was filled with hot gas, tiny particles, and random energy. It took hundreds of millions of years just for stars to form, and much longer for galaxies to take shape. And even when galaxies did appear, they were expected to be messy. Small clusters of stars scattered like cosmic debris. They were not supposed to be organized. They were not supposed to have structure. But this galaxy had it all. Not only that, its light contained something even more surprising: heavy elements. Scientists found signs of carbon, oxygen, and even traces of iron. These elements were not created in the Big Bang. They're made inside stars, then spread through space when those stars die. For carbon or iron to exist in large amounts, entire generations of stars must have lived and exploded before the galaxy could form, and that would take time. Time that didn't exist yet, which means this galaxy somehow evolved faster than any model predicts. It formed stars, created heavy elements, and built structure at a speed no one thought was possible. Even stranger, the galaxy's core gave off strong energy signals, like those from quasars, which are powered by supermassive black holes. If true, then a black hole had already formed at the center and was actively feeding just a few 100 million years after the birth of the universe. Everything about this galaxy broke the rules. Its shape, its age, its chemical makeup, its energy. James Webb didn't just capture a beautiful photo, it captured a paradox, a galaxy that should have taken billions of years to grow, but appeared far too soon. And once that first image was confirmed, scientists had to ask, was it just a one-time mistake? Or were there more like it? At first, scientists thought the galaxy might be a rare glitch. Maybe it was just one strange object. Maybe something had gone wrong with the instruments. But James Webb kept looking. And the deeper it looked, the more galaxies it found. Not one, not two, but dozens. All of them were too big, too organized, and too rich in heavy elements to belong in that part of the universe's timeline. Each one was like a fingerprint left behind by something we didn't understand. They didn't match the chaotic clouds of gas that were supposed to exist in the early universe. They looked old, they looked structured, and they were everywhere. This was no accident. The galaxies shared traits that made scientists nervous. They had strong cores, spiral patterns, and clear signs of chemical evolution. Some even glowed with energy patterns seen in galaxies that are billions of years older. The chemistry told its own story. Instead of showing just hydrogen and helium, these galaxies contained carbon, oxygen, silicon, and even metals like magnesium and iron. These elements are made when stars live, burn, and die. If they were present in the early universe, it would mean that stars had already gone through multiple life cycles. But how could that happen so quickly? There wasn't supposed to be enough time. These discoveries left no doubt. This was not an error caused by the telescope. It was confirmed by multiple studies using different instruments. Independent research teams from around the world reviewed the data. They found the same galaxies in the same place, with the same strange properties. The light from these galaxies had traveled for over 13 billion years, yet they looked like they had already lived full lives. It was like finding a full-grown tree in a forest that had only existed for a day. No model could explain them, no equation could predict them, and every new image made the mystery deeper. One galaxy might be an exception, but 2, 3, a dozen. That was a pattern, and patterns need explanations. As the discoveries kept coming, scientists started to rethink everything they knew about the early universe. If these galaxies were real, then our timeline of cosmic evolution was wrong. Something either made the universe grow faster than expected, or the rules we used to understand it were incomplete. Either way, the foundations of modern astrophysics were shaking, and the telescope had only just begun its mission. What would happen if time itself wasn't flowing the way we thought? For most of modern science, time was treated like a straight line. It moved forward, 1 second after another, the same everywhere. But what if that was never true? What if time, like space, could stretch, bend, or even break? That idea, once limited to science fiction, is now being taken seriously by astrophysicists. Because the galaxies James Webb discovered don't just challenge our models of space, they challenge our understanding of time itself. Some scientists have proposed a bold theory called cosmic time bubbles. These are regions in the universe where time flows at a different rate compared to the space around them. Inside one of these bubbles, time might move slower or faster depending on the density of energy or the shape of space-time. If the galaxy James Webb saw was inside one of these pockets, it might have had much more time to evolve, even though the rest of the universe was still young. From our point of view, the galaxy appears impossibly old, but from inside that bubble, maybe it had billions of years to grow. This would explain why it looks so advanced. It also means we might be looking at more than a distant object. We could be looking across a boundary where time itself behaves differently. There is some precedent for this idea. Einstein's theory of general relativity shows that gravity affects the flow of time. Clocks run slower near massive objects like black holes. If gravity can distort time on a local scale, maybe energy fields or early universe physics can do the same on a cosmic scale. That would mean time is not a constant. It is something shaped by the universe, not something that shapes it. This theory also opens up new questions. Could there be regions of space where time never flowed normally? Could some parts of the universe still be stuck in a slower state, hidden behind veils of warped physics? And if time can behave differently depending on location, how can we ever be sure what early or late really means? Maybe we're not seeing galaxies evolve too fast. Maybe we're seeing galaxies evolve on their own schedule, in a part of space where time moves to a different rhythm. It's a rhythm we don't yet understand, but it might be the key to solving the mystery. Because if time can stretch or fold, then what else could it do? Could it loop? Could it cross? Could it connect us to something beyond? The deeper scientists looked into the data, the stranger it became. The galaxies James Webb discovered weren't just older than expected. They seemed to break the rules of how our universe is supposed to work. Some of them were too isolated. Others showed patterns of matter that shouldn't exist. And a few had chemical compositions so unusual that no current model could explain them. At some point, the standard theories stopped making sense. That's when a new question appeared. What if we weren't looking at galaxies inside our own universe? What if we had seen something bleeding in from another one? This is the heart of the multiverse theory, the idea that our universe is just one of many. Each universe could have different laws of physics, different timelines, and different structures. Some might be expanding faster, some might be colder, some could be nearly identical to ours. And once in a while, two of them might interact. Some researchers now believe that the galaxies James Webb captured may not belong entirely to us. They could be echoes, projections, or overlaps from another universe running beside ours. This theory is not just imagination, it has roots in real physics. Quantum mechanics, string theory, and inflation theory all allow for the existence of parallel universes. In some models, space itself can split, with each version evolving in its own way. And in rare cases, those versions might leave behind traces, signals, distortions, or strange objects that don't fit. One idea gaining attention is that Webb might have observed a gravitational lensing effect from another realm. The telescope could be detecting a distorted image of a galaxy that technically exists outside our universe. Another theory suggests we are living in a holographic universe. That means everything we see is a three-dimensional projection from a two-dimensional reality. If this is true, then the galaxy Webb found might not be a solid structure. It could be a ripple, a fold, or even a glitch in the fabric of space. That possibility, as wild as it sounds, is supported by some of the math in black hole physics. And if it's real, it changes everything, because it means we are not alone in our reality. We are part of something bigger, something layered, something we have only begun to touch. Could that galaxy be a message? Could it be a signal from another version of space? Or is it simply a mirror showing us how little we truly know? Whatever the answer is, one thing is clear. The James Webb Space Telescope didn't just find a distant object, it opened a door. What happens when you find a galaxy that looks older than time allows? You start asking deeper questions, and one of them might be the most important of all. Could life have existed in that galaxy before Earth was even formed? At first, the idea seems impossible, but when scientists looked closely at the galaxy's light signature, they saw more than just stars. They found signs of carbon, they saw oxygen, and they even detected traces of iron and other heavy elements. These are not just random chemicals, they are the building blocks of life. Carbon forms the backbone of all known living cells. Oxygen supports energy systems. Iron helps move that energy. On Earth, these elements came from ancient stars that exploded billions of years ago. Then they drifted through space, joined together, and slowly formed planets. But in this galaxy, they were already present, not in small amounts, but in concentrations that suggest an entire generation of stars had lived and died, possibly more than one. That means rocky planets could have formed early, very early. And where there are planets with carbon and oxygen, the door to life is at least partly open. This discovery changed the timeline for habitability in the universe. Scientists used to believe that complex life needed billions of years of cosmic evolution. Now that belief is being challenged. If the building blocks were available within the first few 100 million years, life could have had a much earlier start. Maybe even before our solar system existed. This raises another possibility. What if intelligent life once evolved in that galaxy? What if it rose, built, explored, and then disappeared before Earth was born? There is no proof of that, but there is no reason to rule it out anymore. James Webb didn't detect cities or signals. It didn't hear voices or see lights, but it saw conditions. It saw chemistry. It saw time. And together they create the possibility that life may have emerged and ended long before we arrived. This isn't just about where life might exist, it's about when. We may not be the first to walk under the stars, we may only be the latest. And if life came and went before us, then the universe holds not just secrets, but memories. Memories written in light, memories that have been waiting for someone to look at. So now the question becomes even harder to ignore. What kind of forces could create galaxies, build stars, and make life possible, then disappear without a trace? The galaxy James Webb discovered didn't just look old, it also looked alone. This might sound small, but in cosmology, isolation matters. Most galaxies form in clusters surrounded by other galaxies, sharing gravity, exchanging matter, and growing through collisions. But this one stood apart. There were no visible neighbors, no signs of galactic mergers, no disrupted arms, no stellar debris. It floated in a silent pocket of space, untouched by the chaos that usually shapes the early universe. That silence raised a new question. How did such a massive and mature galaxy grow without help? How did it form structure without nearby galaxies to interact with? The answer might lie in something even more mysterious: primordial black holes. These are black holes believed to have formed just moments after the Big Bang. Unlike the ones born from dying stars, primordial black holes could have appeared from pure energy and density. Some theories suggest they came into existence when the universe was only a fraction of a second old, and if that's true, they may have acted like seeds. Seeds that pulled in gas, triggered star formation, and shaped galaxies around them. Instead of tearing things apart, these black holes could have helped build. In this theory, a black hole sat at the center of the ancient galaxy James Webb saw. It wasn't a monster swallowing everything. It was an architect, gathering mass, organizing structure, and powering the bright core scientists observed. This would explain the strong energy signals coming from the galaxy. It could also explain how it became so organized so quickly. The black hole may have provided the gravity needed to stabilize the spiral arms, ignite star formation, and maintain structure over time. It turned a chaotic region into a galactic system. This flips our view of black holes. They're not just cosmic endings, they might be cosmic beginnings. And if primordial black holes really played this role, they may be responsible for many of the galaxies we see today, including the strange early ones found by James Webb. The idea is still being tested. There's no direct proof yet, but it fits the patterns. It answers questions, and it opens a new way to think about the early universe. What if the things we once feared, darkness, collapse, gravity beyond control, were actually the forces that made life, stars, and structure possible? Maybe creation doesn't always begin with light. Maybe it begins with shadow, And maybe the oldest galaxies in the cosmos were born not from chaos, but from something far more focused. Something we're only beginning to understand. At every step, James Webb has pushed science closer to the edge. It found galaxies that should not exist. It revealed chemistry that broke the rules. It showed time behaving in ways we never expected, and it hinted at the possibility of other universes bleeding into our own. But now, the most unsettling idea of all is taking shape. What if we've been asking the wrong questions? What if the problem isn't out there but in how we see? For decades, scientists have used equations, models, and simulations to map the universe. These tools helped us measure distance, track light, and define time. They became the language of the cosmos. But what if that language only works in a small part of reality? What if our instruments and theories are too limited to understand the full picture? Some physicists now believe that the galaxies discovered by James Webb are not mistakes or exceptions. They are signs that the foundation of cosmology is cracked. The rules we've trusted about expansion, gravity, time, and matter might only apply within a narrow zone. Beyond that, everything shifts. In this view, the universe is not a single, clear story. It's a layered structure, shaped by forces and dimensions we can't fully detect. Like reading a book while missing every third word, we may be blind to the true message. This doesn't mean science is broken. It means science is evolving. It means we've reached the edge of what current models can explain, and it's time to build new ones. Just as Newton gave way to Einstein, today's cosmology may soon give way to something deeper, something stranger. The galaxies that should not exist have become mirrors. They reflect our limits. They show us that understanding the universe is not about finding the final answer. It's about recognizing how much we still don't know. And maybe that's the point. Maybe the universe isn't here to be solved like a puzzle. Maybe it's here to remind us that curiosity is infinite. That wonder never ends. And that every time we think we've reached the truth, the cosmos reveals another layer. So now we're left with a choice. Do we keep forcing reality to fit our rules, or do we change the rules to fit what reality is trying to show us? Because the galaxies aren't lying. They're waiting. And the real question now is, are we finally ready to listen? The James Webb Space Telescope was built to look back in time, to see the first light after the darkness, to map the early universe and confirm the stories we've told ourselves for decades. But instead, it found something else. It found a galaxy that shouldn't exist. Then it found more. And with each new discovery, the universe whispered a message that echoed louder and louder. We don't know as much as we thought we did. Our maps may be wrong. Our timelines may be broken. Our models may be only shadows of a deeper truth, and that truth is still unfolding. Because every piece of light that reaches Webb's mirrors is not just a clue from the past. It is a challenge to the present. It asks us to stop pretending we've figured it all out. It dares us to wonder again, to question harder, to let go of what's comfortable and embrace what's possible. This isn't just a story about galaxies or black holes. It's a story about how we see, and about whether we're willing to change. Science isn't about being right. It's about getting closer to something real. And in that sense, James Webb has already succeeded beyond anyone's dreams. It reminded us that mystery still exists, that the unknown is not our enemy, it's our invitation. And maybe, just maybe, the greatest discovery of all wasn't a distant galaxy. It was a new way of looking. Because in the end, the universe doesn't wait for us to catch up. It simply is. But the moment we choose to follow the light, no matter how strange it gets, is the moment we remember why we look at the stars in the first place. Not just to explore space, but to explore ourselves. And if this is only the beginning, then the real question becomes, what will we find next?